Welcome to today's lesson on oxidation and reduction. In our last lesson, we learned about theoretical, actual, and percentage yields. We defined and demonstrated theoretical and actual yield, and calculated the percentage yield of chemical reactions from information that was provided to us. In today's lesson, we are going to define oxidation and reduction in terms of electron transfer. We will look at examples of each of these. We will also define the term redox reaction and demonstrate some changes that involve them. Let us get started with our lesson. Oxidation is the process in which a substance loses electrons in a chemical reaction. Let us look at an example. For this reaction of sodium and chlorine to produce sodium chloride, each sodium atom has lost one electron and has turned to a sodium ion. This means that sodium has oxidized. Reduction is the process in which a substance gains electrons in a chemical reaction. Let us look again at our example. In this reaction, each chlorine atom has gained an electron and has changed to a chloride ion. This means that chlorine has been reduced. Students, let us do an activity. In a moment, you will see several processes. Determine whether they are oxidation or reduction reactions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to determine whether each process is an oxidation or a reduction reaction? Processes A, B, and D are all reduction reactions. Process C is the only oxidation reaction. If you got those answers correct, well done. Oxidation and reduction are processes that happen at the same time. While one substance is losing electrons, the other substance is gaining them. Since this process involves an exchange of electrons, it results in changes in the oxidation number. Oxidation is an increase in the oxidation number, while reduction is a decrease in the oxidation number. What is an oxidation number? Oxidation number, or oxidation state, is the number of electrons that an atom appears to have gained or lost when it is combined with other atoms. You will learn more about oxidation number in your next lesson. Students, let us do an activity. Using our previous example, please write down which element is being oxidized and will thus experience an increase in oxidation number, and which element is being reduced and will thus experience a decrease in oxidation number.
Students, let's get ready. Begin. Thumbs up. Let's get back to our lesson.
Welcome back, students. If we look back to our previous example, we can see that sodium is being oxidized and will thus experience an increase in oxidation number from 0 to +1. We can also see that chlorine is being reduced and will thus experience a decrease in oxidation number from 0 to -1. If that is your answer, good job. Let us continue. Oxidation and reduction reactions are called redox reactions. Oxidation and reduction take place at the same time in a given reaction. Students, let us work through an example together, and then you can each try one on your own. Let us identify the oxidizing agent, reducing agent, the substance oxidized, and the substance reduced in this reaction. First, we will assign oxidation numbers to all of the elements of the reactants and the products. In the reaction, the sulfur atom in hydrogen sulfide increases its oxidation number from -2 to 0. Therefore, sulfur is oxidized and hydrogen sulfide is a reducing agent. The oxidation number of bromine is decreased from 0 to -1. Thus, bromine is reduced and is an oxidizing agent. Students, now you are ready to analyze a reaction on your own. Name the oxidizing and reducing agents for this reaction.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. How did you do, students? Let us go over the answer together. First, we write the oxidation number of each element and identify the substances which undergo a change in oxidation number. This will show us that copper is a reducing agent and nitric acid is an oxidizing agent. We have learned about oxidation and reduction reactions, or redox reactions. But is there such a thing as a non-redox reaction? Yes, there is. In non-redox reactions, oxidation and reduction do not occur. No electrons are exchanged between the reacting substances. Therefore, the oxidation numbers of the atoms do not change. Non-redox reactions usually involve the exchange of positive and negative ions. Most double displacement reactions and acid-base reactions are examples of non-oxidation reduction reactions. In today's lesson, we learned about oxidation and reduction in terms of electron transfer. We also learned about redox reactions, some changes that are involved, and a little bit about non-redox reactions. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.